So good afternoon, everybody. It's just gone 12 in Melbourne time, so it is now afternoon. Thank you very much for joining us. My name is Paul Marley, Technical Training Manager from HYTALK Australia, and I'm presenting another webinar today on filtration. And without any further delay, let's begin this. I'll just introduce this first. I just need to share my screen. Okay, so we're in the midst of a filtration webinar series on filtration, and this is episode 4 of 11. So this is all about suction filtration, and thank you very much for joining us. Again, formally, I'd like to welcome you back. This webinar series, we have, as I said, there's 11 webinars that we're doing on filtration. This is episode 4 on suction filtration. So we've done the important fundamentals, and now we're moving on to look at the options that are available to you as a product in these filtration sort of solutions, and where and how you can apply them. Okay, so this episode is on suction filtration. All right, we'll start with the poll. If you can check your poll tab, have you experienced a situation where suction filtration has caused a failure? Okay, because I'm going to be talking about the potential for a failure if this is applied incorrectly. I'm wondering if anyone's actually seen that. Okay, so please go to the poll tab and I'll continue. If you can just click on that, that'd be great. I am interested in your responses. Okay, one thing I've realized I haven't done is discuss the schematic symbol for a filter. So I better get that cleared away now. The schematic, according to ISO 1219, is in a diamond shape. And this is because a diamond shape is a preparation device. So things like heat exchangers, drying devices, filtration, these prepare the fluid. So the preparation devices are going to be in diamonds. And of course, the strainer, as you can see on the presentation there, we've just basically got a dashed line to say, well, that is straining as we pass through. Okay, so that's the basic symbol for a filter. An indicator can be applied many different ways, but that's a typical kind of indicator. So what that is essentially reading the pressure differential across the element and telling you what that is, so that when it's time to change the element, you know it's time to change the element. So that's a typical indicator right there. A filter often has a bypass, and that is there to protect the system in case of the filter not getting exchanged, the filter element not getting exchanged. More about that in, I suppose, the next webinar that we're going to do. But that's the symbol for a filter with a bypass, and then a long dash, short dash line around an item is the limits of a sub-assembly, and that's going to say, well, that whole thing that includes the filter, the bypass, the indicator, and anything else, that's one assembly. So that's the symbol for a filter assembly. And that's the one that you'll typically see on many hydraulic schematic circuits. Okay, that's the schematic symbol, done. It pretty much doesn't change much. All right, so part 1, what is suction filtration? Well, I can answer that in one slide. Suction filtration is when we place the filter before the pump, that is in the suction line. So essentially, we've got different places we can put filtration. Today, we're concentrating on that. Okay, so the advantage of doing that is that the pump is protected. Okay, now this makes sense as the pump is sensitive to contamination. It's one of the most sensitive components, mainly because of the clearances and the speeds it's often doing. So it makes sense to protect the pump. And as a consequence of that, this will ensure that clean oil is going through the pump, and we should have reliability as an outcome. So that's the idea in theory. The disadvantage of suction filtration is that the pump can be at risk. Okay, this is because the pump is very sensitive to cavitation. Now, cavitation is a difficult thing to explain, but I can tell you that it's incredibly damaging. Here's a photo of a lens plate from a rather large pump, and that's a very deep cavity there. That's been created by cavitation. So you can see that it's very, very damaging. So cavitation, in a 10-second explanation, is that you have a partial vacuum developing inside the pump, and that then creates a vapor bubble within the fluid. And those bubbles will expand. And then as the pump is then creating pressure, those bubbles of vapor snap back. And that is incredibly damaging. Now, that's the 10-second explanation. With regards to a more complicated explanation, I found a fantastic video recently on YouTube, and I'd like to share that with you. So we're going to put the link in the chat. Don't click on it now. Watch me instead, all right? But once this is over, we've learned a few things. Please go there and have a look at that video. I can't remember how long it goes for, about 15 minutes maybe. It's a scientific explanation of cavitation and some applications of where it exists. So a very interesting video, and that'll answer any question you have on cavitation. Okay, so please avail yourselves of that. But I'm going to move on. Now, because of the risk of cavitation, the filtration can only really target coarse particles, because fine filtration is typically going to cause cavitation to occur. Okay, so when I say coarse particles, I'm saying, well, typically a strainer is applied, and those strainers have a clearance of about 100 microns or even more, 120 microns. So in terms of the particles that are damaging to these systems, that is huge. That is really, really large. Literally, this stuff will keep out rocks, stones, cigarette butts, anything else, low-flying aircraft, whatever you're going to find in that tank. It's going to keep it out of the pump. But it's important to understand that the coarse contaminants are going to be excluded from part of the system. And when I say part of the system, that part being the active part, the loop itself. We're going to exclude the coarse contaminants, but they're not going to be removed from the system, because typically the suction strainer is there just to keep stuff out of that pump. So it's what we call a surface filter. So a surface filter means it just simply filters across one single surface. And the best way to explain it is like a drain grate, because if you want to keep rocks, children, tennis balls out of a drain, of course, you put a little mesh there that is smaller than the thing you're trying to exclude. Right? So that's basically how it works. But you're not removing that contaminant from the environment, of course. You're just keeping it out of where you don't want it to be. That's the role of a suction strainer. So very coarse filtration. Now, ultimately, what that means is the coarse filtration isn't going to clean our fluid to a level that we need really to safely and reliably operate our system. Okay, but it is going to protect the pump if the pump is at danger. So this is a lovely photo that one of our people that came in for training gave me. And I just looked at this. I just thought, yeah, okay, I've seen this many times. Some systems just plain need suction strainers. Okay. And you can see here how bad that is. Now, the danger with this then is that if you do have a filthy system like this, these can clog up. And of course, even though it's very large particles, they can still clog if your system's very dirty. And that will then in turn cause cavitation. So think about it. You put this in there to protect the pump. But if you're not maintaining a clean system, you're putting the pump at risk. You're not protecting it. You're actually giving it a reason to fail. Okay? So clean oil is what you need. A suction strainer won't clean your oil. Okay, so I would say apply it elsewhere. Just a random point I'd like to bring up. I've just got a catalog page here. I found this interesting. This was one of the products that we have with the suction strainer. I've not seen it anywhere else. This has a bypass as an option. Okay, so there's a model code that gives you an optional bypass. And the idea with that is if this does clog up, that will then open. It's a spring-loaded little valve and allow the pump to draw fluid. It won't be clean fluid, but it'll be fluid. And that'll basically keep your pump running a little bit longer. Okay, so a bypass is a thing in suction strainers. Just a random fact. Okay. Suction strainers is something that you're going to typically put in the bottom of a tank. So if you're going to do that, well, it becomes a service item. So that means then you're going to have to replace it. Now, I've just found an image here. This is a complex system. That's all I'm trying to demonstrate. If you had a system like this and you had a suction strainer in the tank, then you're going to have to replace that suction strainer. Now, my advice to you is if you have a deep tank, it's very difficult to change that suction strainer. You have to drain that tank. There are some tanks that I've literally had to bodily crawl into, climb up and down and stand in there to get down and get the suction strainer out. This is not good, okay, because filthy service fitters should not be in hydraulic tanks. Okay, so if you have a deep tank, if you have items mounted on the tank, it's going to be difficult to remove all those items to get that lid off to get to your suction strainer. If you have critical cleanliness needs, then you don't want people to open that tank up anyway. And particularly if it's a dirty environment. I mean, say you had a mining environment, agricultural environment, you don't want anyone to ever open that tank up if possible, okay, just to change a suction strainer. If overhead access is difficult, sometimes, for example, you might have heavy items, manifold blocks and things on the tank. If you don't have overhead access where you can get a crane in there and do it safely, you don't want to be opening that lid up. So if you don't like excessive downtime and excessive labor costs and really just difficult jobs, then you should reconsider placing a suction strainer in that reservoir. Okay, there's really other ways you can do your filtration more effectively. So yes, there's advantages to suction filtration, but there's also disadvantages, and you can see in the application of it, you can make some bad decisions. Then you should consider mounting a suction strainer or filter outside the reservoir. Okay, that way basically you can get access to it, and that's then going to be serviced. Means it's going to remain in a useful condition and it's going to be protecting the pump. Okay, and it's not hidden from view. I would argue a lot of suction strainers don't get changed because people don't know they're there. They might go into a system and stay there forever. So yes, try and make it accessible if you're going to fit it at all. So I've got an example of that. This is a system that's used on a mobile machinery. So this looks like a return line filter, but it's actually a suction filter. And this goes, as you can see, it gets screwed into the side of the tank. Now, the tank being a large tank on an active air blast cooler. Now, this has a valve in it. And you can see the valve over here, and there's the opening over here. So what happens here is then the element, which isn't shown here, when the element is removed, as you open up the lid of the filter housing, that valve on the back is spring-loaded and it's going to close. So you lose only the amount of fluid that's in your housing. You don't have to drain the tank to be able to change that strainer. So there's options to make these things more serviceable. Okay, so these are solutions, and if you have any questions about where you can apply these things, of course, we can help you with that. Okay, so in summary, suction filtration can be done. Typically, you can apply it, but also apply caution, okay, because it is a problematic thing for many, many applications. If you do apply it, it becomes a service item. So that service item should be serviceable, okay? Make it accessible. That's a pretty important tip. Generally, with regards to fine filtration in the suction line, you want to oversize it. You want to make it nice and big. You want to avoid cavitation at all costs, okay? And you can apply fine filtration elsewhere in the system. There's other places where you can get your cleanliness from. So suction filtration, yes, it does protect the pump, but it's not the only filtration in the system. And quite typically, suction filtration is very coarse, and as a consequence, you're not going to get the fine cleanliness levels that you really desire in these oil systems. Okay, so that's pretty much all I have to say on the suction filtration. As I said, this is number 4 of 11. So there's 7 more episodes in filtration story to go. So, you know, collect the set. Please tune in. If you like it, if you find us on YouTube, click like. Feel free to comment. We're interested in your comments. Engage with us in social media, of course. We're on Facebook, we're on LinkedIn, we do the Twitter thing and all of that. So the more you engage with us, of course, the more we get validation, and that's what it's all about. Thank you for your support. Well, that's me done, ladies and gentlemen, and I really appreciate you tuning in. So the next one's scheduled for 2 weeks' time. As I said, that's pressure filtration. So until then, stay safe, all the best, and we'll see you down the track. Cheers.